What's up, everyone? We have in this video two cylinders, one upstream, one downstream, and they're separated by 5 diameters downstream. The one downstream is also staggered, so I've put it up a little bit, exactly 1 diameter. So the top side of this cylinder corresponds with the bottom side of this downstream cylinder. This video shows the vorticity magnitude, the absolute value, and I wanted to see how the von Karman Street now in this scenario impacts the one downstream. So just before I play the video, you can see that the von Karman Street has formed on the first one. And as I play, you can see that it does come off. One really important thing to note is that the top vortex is of one sign, the bottom vortex is of another sign, the opposite. And that's important because this top vortex from the upstream cylinder coincides with the bottom vortex of the downstream cylinder. So there are 2 different signs, the opposite signs, so they'll cancel out. And you can see this happening if you keep an eye on it. So just here, they're starting to hit each other. And as you keep an eye downstream, they kind of merge, they kind of cancel out a little bit. And you can tell that by if you look at the strength of the top vortices compared to the bottom vortices, the top ones are generally, they have a higher vorticity magnitude and they're usually going to be stronger. Now, the bottom vortex from the upstream cylinder is now going to be sort of merging with the bottom vortex of the downstream cylinder, and they go downstream together. So does this pattern here sort of creates an asymmetry in the vortex magnitude of the downstream cylinder. So the ones on the top are bigger and stronger than the ones on the bottom. This video shows the pressure. So along with the vorticity, the pressure is quite important because each vortex is going to have a low pressure core. And so nothing really unusual with the upstream cylinder. You do have that high pressure at the front because of the stagnation. Below, the downstream cylinder has a lower high pressure at the front. And that's because of that other vortex hitting it. Now, see right there, it really drops when that other vortex comes along and impacts it. And then it grows. So that's pretty cool. And the downstream pressure, you can sort of see that there is a bit of a weaker core for this bottom series of vortices. That's because of this upstream cylinder there. These vortices are canceling out. The top vortex is canceling with the bottom vortex, so you don't get much of a low core compared to the top vortices. And this video shows the U magnitude. It's quite interesting because I wanted to see what the U magnitude was because it gives you an idea of what the flow is doing. And the von Karman Street, or the first one, that's doing its thing. But the downstream von Karman Street is taking on a little bit of a different look to what we're used to. So I'll play it a little bit for you to see. And so here we have quite a few vortices. And unlike a regular von Karman Street, which is where they're sort of staggered and they're around the center line, these are all very much in line. So these low velocity cores, they're all very much in line. So they sort of straightened up this von Karman Street a little bit. And this video shows the U Y velocity, so the up and down, red is up, blue is down. And this gives us an idea as to how much the flow is moving up and down. So I mentioned before how it was a lot more in a line, a lot more aligned. This will give us a clue as to why that is. So we have the upstream cylinder, the downstream cylinder. And as the flow goes downstream, we can kind of see that compared to the first cylinder wake, the von Karman Street in the first cylinder, the downstream one is not nearly as intense. So you can see how these are much lower and much higher. These aren't as high or low. And they're all kind of aligned. So that's this video of tandem cylinders which are misaligned. Make sure to check out the Atmosphere Hawk. This is one of our instruments that we make. It'll make all your lives better in your experiments. We also have the International Aerodynamics Conference. It's a conference that we put on every year for aerodynamicists. and check out the courses we do to make you a better aerodynamicist. Links in the description.